Okay, Assalamualaikum and good day, everyone. So, first of all, I would like to apologize. So, this is already week 14, and I only managed to prepare the slide and video now. So, however, I hope that this presentation will still be useful, especially to help improve the result and discussion section of your FYP report. So in this section, I will focus on how to present result more clearly, how to interpret them properly, and how to improve your result presentation for better understanding and marks. So I will not be turning on my video to help ensure a smoother internet connection. So I hope this session will still be helpful, especially in improving your presentation. Thank you, and hope this session can help you at least a little. Okay, let's start with the main idea on this slide. So from evidence to impact. So many FYP2 report have one common witness. So as I state here, the main witness in FYP2 reports, both technical paper, TP, and final report FR is a poor interpretations. So students usually have data. You do experiment, simulation, and collect result. But the problem is what you do after that. So strong research is not about more data, so as written on this slide. So it's about better explanations. You may have many graph and tables, but if you cannot explain what they means, so the research is still considered weak. So this is why evidence alone is not enough. So as a highlight here, evidence must be translated into meaning and impact. So in FYP2, you are expected to explain what the results show, why the behavior happens, and why the finding is important. So lastly, take note then of the final point on this slide. So AI is used as an academic support tools, not a shortcut. So AI can help you think, structure idea, and improve explanations. But this cannot replace your understanding. Okay, so if you cannot explain your result clearly, then the problem is not the language. The problem is the thinking. Okay, now let's look at why most FYP report underperform. I start at the top of the slide. So one common issue, as listed here, is the result are descriptive rather than analytical. So many report only describe what is seen in the graph, but they not analyze what the result actually means. Okay? So the next issue mentioned is that the graph and table are presented without interpretation. So student put in many figure, but after that there is little explanations. The reader is left to guess to guess why the trend happened. So another serious problem is when the discussion replaces the result instead of analyzing them. So this means this discussion section simply repeat the results using different words. There is not discussion. Then we come to the conclusions. As written here, conclusion often lack justification and meaningful impact. So claims are made, okay, but they are not clearly supported by earlier analysis. So please pay attention to the key message at the bottom of the slide. The main weakness in many FYP report is not the experiment design. So it's the lack of depth of analysis and interpretation. So this is where students usually lose mark. Even when the data itself is actually good. Okay. Now pay attention to the key message on this slide. So evidence, insight, and the impact are not the same. So first, let's look at evidence as shown here on the left. So evidence refer to raw data, measurement and graph or simulation output. So this is what you collect from experiment or simulations. However, evidence alone is not enough. Next is insight, as listed in the middle. So insight is when you provide an explanation of trend and behavior. So you explain why the result change and show cause and effect reasoning. So this implementation must be supported by theory, not guesses. So then come impact, which is shown on the right side. So the impact explain what these findings actually means. So how do they affect system design, performance, efficiency, or real world applications? So many students stop at evidence. So some manage to provide insight, um, but very few clearly explain the impact. So that is why the note at the bottom of this slide is very important. Examiner award mark mainly for insight and impact, not evidence alone. So remember, evidence show what happened, insight explain why it's happened, impact explain why it's matter. So that is the level expected in strong FYP2 report. Now let's look at what's examiner actually look for in FYP2. So the first examiner check whether result clearly address the status the state's objectives. Okay, so as written here, each result must directly relate to specific objective. So if an objective has no supporting result, uh, then the objective is not achieved. So next, examiner look at whether discussion explain why the result occur. So discussion should go beyond descriptions. So it must focus on interpretations, not just restarting what is already shown in the result. So another important point shown here is about engineering theory. So explanations must be supported by relevant engineering principles. So theory is used to justify trends, behavior, or any unusual results. So examiner also expects students to acknowledge limitations and implications. You need to state what the study cannot fully address or measure, and explain how this affect the result and possible future improvements. So finally, examiner check whether the finding answer the original problem statement. So your discussion must clearly show how the result helped to solve the problem, not just the experiment was successfully completed. So remember this, examiner are not reading to see how much data you have, but to see how well you think, explain, and justify your result. So this is where most of the mark come from. Okay, what often happen in FYP is a gap in the way students think about research. Most students follow a very typical workflow. So you run the experiment, plot the graph, write the report, and then submit. So the focus is mainly on finishing the step, not on understanding the result. So, but research should not stop at plotting graph. So after the experiment, and the next step should be interpretations. You need to make sense of the results. Then you analyze their behavior. So and justify what you observe using engineering theory. Only after that can you discuss the finding properly. So and finally derive the impact of your work. So this is where many reports are weak. Okay, they jump too quickly from result to writing. So without spending enough time thinking in between. So the real issue here is not effort, it is the thinking gap between result and discussion. So if you want stronger FYP2 marks, you must move away from simply doing tasks and focus more on understanding, analyzing, and justify your result. So that change make a clear difference in report quality. Okay, good research always follow a clear logic change. So everything start with the problem statement. You need to clearly define the real problem or gap that you are trying to address. If the problem statement is weak or unclear, the whole research become confusing. So from there, you move to the objective. Okay, so objective state what the research aim to achieve in order to solve the problem. So well-written objective guide what you should do next in your study. So after that comes the method or experiment. So this is where you design and conduct experiment or simulations to meet the state's objective. So then you present the result. So the result include your data, graph, and measure output. In this stage, you are only showing what you obtain, not explaining why. So next is the most important part, which is interpretation and discussion. Here you explain what the result mean and justify the behavior using engineering theory and reasoning. So finally, you must explain the impact. Impact shows why your findings are important, how they affect system design, performance, efficiency, or real-world applications. Okay, so when this logic chain is clear and well connected, so your report become structured, logical, and much easier for examiner to understanding and access. One very common confusion in FYP report is the difference between result and discussions. So let's start with result. So results are objective-based finding. So there are data and measurement. So you present result according to each research objective using graph, table, and measure outputs. Result shows evidence, and result also highlight observed trends. You show clear pattern, change, or difference seen in the data. So at this stage, you are not explaining causes yet. Now let's move to discussion. So discussion is the interpretation of the result. So here you explain why the observed trend occurred. You link the explanation back to the objective and the original problem. So discussion must also use theory and acknowledge limitation. So engineering theory is used to justify the behavior, and assumption or limitation are explained. So remember this key idea shown here. So result provide evidence, discussion provide proof. So if you make these two sections, so the report become confusing and weak. Keep result clear and factual. Use discussion to think, explain, and justify. So that explanation alone can greatly improve your FYP report quality. One very important rule in FYP2 is each objective must be supported by at least one result. When you write your report, result should not be organized based on the order of experiments. Okay, so they should be organized based on the objective. So if an objective has no result to support it, so then the objective is considered not achieved. So even if other result look good, so for example, if your objective is to analyze efficiency under varying load, so then your result should clearly show efficiency versus load. So such as a curve or table that directly answer the objective. So every result must have a clear purpose. So you should be able to answer one simple question, like what objective does the result support? Okay. If you cannot answer that, so then the result does not belong in the result section. So this alignment help the examiner immediately see that your study is structured, focused, and designed to answer the objective, not just to show the data. So clear alignment between objective and result is one of the easiest way to improve FYP2 marks. Okay, after aligning result with objective, so the next step is to align the discussion with the problem statement. So a strong discussion must be able to answer one key question. How do this result address the problem statement? So you must clearly explain how your findings help to solve the problem. So that was identified at the beginning of your study. So next, you need to explain why the solution matter. What is the value of your results? So this is it improve performance, efficiency, accuracy, or understanding of the system. Another important point is to answer whether the problem is fully solved or only partially solved. So not all problems can be solved completely, and then that is acceptable in FYP2. So what is not acceptable is ignoring these questions. If your discussion only explain the data but does not link back to the problem statement, then the research is considered incomplete, even if the result look technically good. So always remember, the purpose of discussion is not just to explain the result, but to prove that the problem is being addressed. So that clear connection is what examiners are looking for. Yeah, there's some common misalignment error that often appear in FYP reports. So the first issue is result not aligned with objectives. So results are presented, but they do not clearly answer any stated objective. So this usually happen when results are organized based on experiment, not based on objective. So the second issue is when the discussion ignore the problem statement. So discussion explain the data, but does not show how the result help, okay, to solve the original problem. So when this happen, so the result look incomplete. Okay. So another common problem is unproven success claim. Some report claim that the system is successful or effective. So, but there is no clear data or just justification to support those claims. So, statement without evidence do not add value. So, the final issue is a weak conclusion. So, conclusion often only restate the objective without referring back to the result and discussions. So, a good conclusion must be based on evidence and analysis and not repetition. So all these misalignment error have one serious impact. So they directly reduce FYP2 marks, no matter how good the experiment or simulation is. So always check alignment between objective, result, discussion, and conclusion. Clearly, alignment is key factor in a strong FYP report. Now, let's be very clear about the correct position of AI in FYP. So AI is not your researcher. This is you need to remember. Okay, so it must not replace your thinking or understanding. So AI is not your data generator. So AI data must come from real experiment or valid simulations. So AI is not your decision maker. You are responsible for every conclusion you write. So what AI can be is a thinking assistant. It can help you organize your idea and think more clearly. So AI can also act as a interpretation support tools. It help you explore possible explanations, but you might decide whether they make sense and are supported by theory. In addition, AI can help with structure and clarity. It can improve how you explain results, but the explanation must still be your understanding. So always remember this balance. AI support your thinking, but it does not replace your academic responsibility. If you cannot explain it confidently during Viva or in your TP, in your final reports, so that AI should not be the reason it appear in your report. Okay, now let's talk about where AI actually adds a real value in FYP2. So the first, AI can help with data interpretations. So it can assist you in analyzing results and identify trend or pattern that may not be obvious just by looking at the graph. So second, AI can help with behavior comparison. So it can compare expected behavior based on theory with observed behavior from your result. So they help you think more critically about your finding. So another important area is theory-based explanation. AI can suggest possible explanation grounded in theory, which can help you reason more clearly. So, but you must still check whether the explanation makes sense and match your system and assumption. AI is also useful for alignment checking. So it can help you identify weak links between objective, result, discussion, and the problem statement. So this is especially helpful before final submission. So the key message here is simple. AI is most valuable when it supports you thinking, analysis, and interpretations. AI does not replace experiments. It enhances interpretation, not experimentation. So when used correctly, AI help you think better, explain better, and produce a stronger FYP report. So now it is a very important to understand where AI must not be used in FYP. AI is a support tool, not a replacement for your thinking, your data, or your academic responsibility. So first, AI must not produce undeniable conclusions. If you cannot clearly explain and defend conclusions, then it does not belong in your report. So next, AI must not create fake references. So every citation and reference must be real, traceable, and verifiable. So AI generated or imaginary references are a serious academic issue. So AI must also not be used to fabricate data. Okay, so you must not generate or modify experimental or simulation result using AI. So all result must come from real experiment or valid simulations. Another common mistake is unsupported claim. So AI must not help you make claims that are not backed by data or analysis. So every claim in your report must be supported by your result. So the final reminder here is the uh, presentation Viva related checks. If you cannot explain it clearly during Viva or during presentation, do not include it in your report. Always remember this principle. AI can help you think and explain, but you are fully responsible for everything written in your FYP. Now, let's look at why prompt quality determine insight quality. So the example at the top show a weak prompt. Explain this graph. So it's very simple and it's a very weak prompt. So when you ask a vague question like this, AI does not know what to focus on. So the answer you get is usually generic, basic description, and not very useful for FYP discussions. So now compare it with the strong prompt shown here. Explain the observed energy consumption. Let's say this is example, just example. Explain the observed energy consumption trend based on system behavior and operating conditions. So this prompt is clearer. It tells AI to focus on behavior, condition, and engineering reasoning. So as a result, the explanation become deeper and more meaningful. So this is why better prompt produce engineering insight, not just general text. So the key lesson here is simple. AI does not automatically give good answer. So the quality of the output depend on the quality of the questions. If your prompt is shallow, so the explanation will be shallow. So if you prompt encourage thinking and reasoning, the explanation will improve. So always design your prompt to sound like an engineering questions, not a question request. They will help you get more useful support from AI for your FYP explanation and discussions. Okay, let's look at the example shown on this slide. First, focus on the weak prompt, which is simply explain this graph. So the explanation that's followed is most descriptive. It talk about what the graph shows, such as increase, decrease, and general trend. But it does not explain why the trend happened. There is no system behavior, no operating condition, and no engineering reasoning. So now compare that with the strong prompt below. The prompt asks to explain the trend based on system behavior and operating conditions. Because the question is clearer, the explanation becomes deeper. So it connects the trend to efficiency improvements, cost reductions, policy influence, and system level factor. Here the reader understand why the trend occur and not just what is happening. So this is the key difference between description and interpretation. So both explanation use English. The difference is not language. The difference is the thinking behind the explanations. So when you use AI, does not ask it to simply explain a graph. So ask it explain the behavior, the reason, and the meaning. Then it's how you move from a weak explanation to a strong engineering-based interpretation. But you must justify it with your knowledge, and then you must verify it properly. Okay, so not only depend on what AI give you answer. Okay, to get useful output from AI, so your prompt must be objective driven. So the first thing you should do is refer to specific objective. Okay, so do not ask in general. Uh, be clear about which objective you are trying to address. Next, you need to identify the related results. So tell AI which graph, table, uh, or output you want to explain. So this keep the explanation focused and relevant. So and then request a theory-based explanation. So do not ask AI to describe the graph. Ask it to explain why the behavior happened using engineering principle and theory. After that, ask whether the objective has been achieved. Uh, this help you evaluate your result more critically instead of assuming success. So finally, request limitation or implications. This encourage deeper thinking and prepare you for a discussion and conclusion writing. So when you prompt, follow the structure, the AI output stay aligned with assignment assessment criteria and examiner expectations. So this framework help AI support your thinking instead of producing generic text. And this slide shows a result-driven prompting workflow so that you can follow step by step. So the first, you start by presenting result correctly. So you use AI to help decide the most suitable graph or table. I will show you the example after this. So and then but remember the result must clearly address the problem statement or the objective. So next, after the result are shown, you move the explanation the result, explaining the result. So here you ask AI to help explain what the result mean, not just what is displayed. So the explanation must clearly link back to the problem statement and the objective. So then you develop the discussions, and then at the stage, AI can help expand your explanations into a structured discussions. So the discussion must justify the result using theory. So do not repeat, not repeat the graph or numbers. So finally, um, you test impact and alignment. You check whether the result and discussion truly answer the problem statement and whether the objective are achieved. This workflow remind you of one important principle. You do not start with from data. You start from the problem and objective, and only then decide what result to present and how to explain them. Following this workflow, help AI support your thinking and help you produce a clearer, stronger FYP. Okay, the first step in writing your result section is to start from the objective or problem statement, not from the data itself. So before showing anything, you must decide what needs to be shown in order to answer the objective. So next, choose the most appropriate presentation format, whether it's a graph or a table. So the format must make the answer to the objective clear and visible. So every result must have clear purpose, and you should always ask yourself what question does this result answer. Avoid showing too many results in one figure or one table. So each result should focus on one objective or one key aspect only. Too much information is one figure will confuse the examiner, the panel. So finally, make sure all answers, label, unit, and caption are clear and correct. So poor presentation can weaken interpretations. So even if the data itself is good. So remember this principle. So results are not shown to display data. So results are shown to answer objective and address to problem statement. Okay, so this slide explain how you should write the explanation of your result in the report. So first, begin explanation only after results are clearly presented. So this means you only start writing after a proper graph or table is already shown. So you should not explain raw data without proper graph or table. Okay, if your result are still number, they must be first be converted into a clear visual presentation. So next, when you explain the result, you might explain what the result indicate and not what it shown visually. So do not describe the graph or the trend lines. Okay, and then also avoid repeating values, label or caption because those are already visible in the figure or table. So then every explanation must be connected to your research aim. You must explicitly link each explanation to the relevant objective. Okay, in your writing, start clearly which objective the result support, so the examiner can see the objective is being achieved. After that, your explanation must move beyond observations, and you need to use appropriate engineering theory to justify the observed behavior. And remember, theory explain why the result occur, not just what happened. So finally, your explanation must relate back to the problem statement. You should show how the result contribute to solving the problem state at the beginning of the project. So overall, this slide remind you that explaining result is not about describing figures. It is about interpretations, justification, using theory and clear align with the objective and the problem statement. We now move to discussions. Here, you write the proof understanding. Do not repeat result. You start discussion after result have been explained, not before. The discussion is built on the explanation you have already written. It built on explanations, not raw result. So, and then if the explanation are weak or missing, the discussion cannot stand. Shift your focus from what to why. So you must focus on why the result occur, not what was obtained. Replace description with reasoning. Explain the mechanism, the operating condition, and the causal factor that produce the trend that you observe. And then you keep the discussion clean and analytical. You avoid repeating graph, table, or numerical value. So the examiner has seen your figure repeating waste space. So use the paragraph to argue, not to copy. So stated every claim with a principle. So use engineering theory to justify trends, behavior, or anomalies. So link your statement to the correct model, equation, or law, so the reader can see that your explanation is technically grounded. So this is where your academic argument gain weight. Make the alignment explicit. You need to clearly show how the finding prove the objective. Each point in this discussion should state which objective it confirmed and in what way. If the linkage is not visible, mark will be lost. So finally, demonstrate research maturity. You discuss limitation and assumption of the result. So this is not weaken your work. It show control and critical judgment. And then state the condition under which your conclusion hold, the sources and of uncertainty, and what's remain to be improved. So this is the purpose of step 3. You argue causes, justify with theory, connect the objective, and acknowledge the limits without repeating the figure. So this is how the discussion section should be developed at the FYP2 level. Okay, this slide focus on checking the quality and alignment of your work before you conclude. First, you review whether the result clearly support each objective. So go through your objective one by one and make sure the evidence is clearly shown for each of them. Because every objective must be backed by evidence. If an objective has no supporting result, then the objective is not achieved. So next, you check if the discussion truly answer the problem statement. So you must not assume the panel or examiner will guess the link. In your writing, the problem must be explicitly addressed, not implied. So state clearly how your discussion respond to the problem you introduced at the beginning. So after that, you evaluate whether the finding are meaningful and impactful. So at this point, ask yourself how the result affect design, performance, or applications, and explain why your finding matter in practical or engineering context. Then you identify any gaps, weaknesses, or missing analysis. Be honest in your writing and acknowledge what is not fully solved, whether it is due to system limitation, assumption, data range, or other constraints. So finally, you conclude whether the objectives are fully or partially achieved. This judgment must match your evidence and analysis because this form the basis for a strong conclusion section. Okay, so this slide introduce the case study that will be used as a running example in the next few slides. So the case study is titled AI-based solar DC current anomaly detection for preventive maintenance. So we are not analyze the paper in detail at this stage. Instead, we will use this case to demonstrate how a real technical study should structure its result, explanation, discussion, and impact. So this case study will help show how result content is organized logically, starting from clearly defined objective, followed by properly presented result, then supported explanation, and finally a strong discussion and conclusions. So the focus is not on copying the paper, but on understanding how the author decide what result is to show and how each result is written to support the study. In the coming slide, the case study will be used to demonstrate how results are selected, how explanation are written based on those results. So how discussion is developed using theory and how alignment and impact are tested. So by following the flow of this case study, you can see how a complete FYP report is built in a structured and accessible way. Okay, so treat this case study as a reference example, not as content to memorize. So it purpose is to guide you on how to organize your own result, explanation, and discussion when writing your FYP report. Okay, in this slide, we look at how a technical paper author decide how to present a result. So, and we used the case study introduced earlier to demonstrate this process. So the key idea here is that results are not presented randomly. So before showing any graph or table, the author start by clearly understanding the problem statement and the objective of the study. So this guide what kind of result need to be shown. So in this step, the author use a prompt to think carefully about result presentations. The prompt asks the author to determine how the result sections should be structured so that the reader can clearly see how the objectives are being addressed. Okay. So the first task is to decide which result should be presented as figure, such as graph, and which should be presented as table. Not all output need to be graph, and not all need table. So the choice depend on what the best communicate the message. So the next, the author decide the correct sequence of result presentation. So the result related to the first objective should be shown before result related to the next objective. Okay, so this help the reader follow the logic of the study step by step. Okay, so for each figure or table, the author also decide the key message that the reader should immediately observe, and this message must be linked back to problem being solved. At this stage, the focus is only on showing evidence, not on explaining causes or discussing implications. So this slide teach an important lesson for writing. Results are designed to answer objective, not just to display output from a model or experiment. When you plan your result section this way, your writing become clearer, more structured, and easier for examiner to access. Okay, what you see on this slide is raw data obtained directly from an experiment. So this is real output from the system. But at this stage, it is not yet a proper result. If we place this table directly into the report, the panel or examiner cannot clearly see uh, how the data answer the research objective. So instead of explaining the number immediately, the correct next step is to decide how this data should be presented. For example, what should be shown as graph, what should be summarized as table, and in what order so that each objective is clearly supported. So this is a way we prompt AI properly, not to explain the data, but to help us design the result section so that the evidence clearly prove our objective. Um, in this slide, we explain the result that have already been presented. So at this stage, the figures such as the ROC curve, position recall curve, and the confusion matrix are already fixed. So the focus now is to describe what each result shows about the CNN model behavior when applied to the real energy data, and how each result support the research objectives. So we explicitly relate this observation back to the problem statement to show relevance to data authenticity and real-time performance. So this explanation is still part of the result section. So we only describe what the result indicate, that how they support the objective without justifying design choice or discussing limitations. Okay, in this slide, we move from interpreting result to explaining why the result occur. So we are now building the discussion where we use engineering reasoning to justify the CNN's behaviors. Explain why the chosen methods such as ROC, precision recall, uh, and confusions metrics are appropriate, and articulate key assumptions and limitations relevant to real-time energy data without repeating numbers or rewriting the result. So the prompt on the slide is designed to push your thinking by asking AI to help you construct a logical, uh, objective-driven argument that tie your finding back to the problem statement and show how they fulfill the objectives. With this prompt, you will obtain a structured discussion that explain the why and strengthen your claims for the purpose of writing a technical paper. So now take this example prompt and adapt it to your own project. What matter most is understanding how to prompt the discussion section correctly. In this final step, we evaluate the overall impact and alignment of the study. So at this stage, the result and discussion section are already complete. So the focus is on checking whether each objective is truly supported by evidence, and whether the finding explicitly answer the problem statement. So using the prompt, we ask AI to act as a technical reviewer to assess the strength of the study, identify any remaining gaps or weaknesses, and evaluate whether the outcome have a meaningful practical impact. So with this prompt, we obtain an objective assessment of how strong, moderate, or limited the study contribution is, helping us refine conclusion and strengthen the work for writing and complete and coherent technical paper. So to conclude, this session was not about teaching you how to use AI to write your report, but about teaching you how to think like a researcher when using it. So we started from raw experimental output, then use structured prompting to design the result section, interpret the finding, develop and meaningful discussion, and finally test impact and alignment as a technical reviewer would. So the key takeaway is that strong research is built on clear logic, objective alignment, and critical interpretations. So AI is most effective when it is used to support these thinking processes, especially in presenting, explaining, and strengthening your work for technical paper writing. If you understand how to prompt correctly at each stage, you will not only improve your report quality, but also produce research that is clear, defensible, and impactful. Thank you to everyone for your attention and participation. So I hope this session has provided useful guidance and practical insight on how to develop the result, discussion, and conclusion section more effectively. So with the right structuring, clear alignment between objective and finding, and proper use of AI as a thinking support tool, I hope uh, this will assist you in producing stronger technical paper and final report. Thank you very much.